And do you know what? If you drove on the moon, you could circle it faster than going around the Earth. First, we need to understand the racetrack. Beyond Earth's atmosphere lies the domain of satellites, while the moon is a realm of silence. It's the dream destination of quiet spacecraft. Earth's gravitational pull is much stronger than the moon's, meaning that orbiting the Earth requires a higher speed to overcome that powerful gravitational force. It's kind of like Earth is a tough coach pushing you to your limits, while the moon is more like a gentle guide. What we need to grasp is the orbital period of an object around the Earth or the moon. The time it takes to complete a full orbit. That duration is determined by several factors, like distance, mass, and gravitational force. According to Kepler's third law, the square of the orbital period is proportional to the cube of the orbital radius. In other words, the farther an object is from Earth, the longer it takes to complete one orbit around it. The time required just keeps growing. Take the International Space Station, or ISS, as an example. It orbits about 408 kilometers above Earth's surface. It takes roughly 90 minutes to go around the Earth once, at a speed of about 7.66 kilometers per second. Geostationary satellites, which are much farther out, at an altitude of around 36,000 kilometers, need a full 24 hours to complete one orbit, ensuring they stay fixed over the same spot on Earth's surface. Now, shifting to the moon, things change once again. The moon's mass is only about 1/81st of Earth's, and its gravitational pull is much weaker. As a result, the orbital period of an object around the moon is shorter. For instance, when the Apollo astronauts went on their lunar missions, their command module orbited the moon at a speed of about 1.58 kilometers per second, with an orbital period of roughly 2 hours. So, if we compare the speeds of objects orbiting Earth and the moon, what fascinating patterns might we notice? First off, because the moon's gravity is weaker, objects in lunar orbit move relatively slowly. But that doesn't mean their orbital periods are longer. In fact, since the moon's radius is smaller, the full orbital path is also shorter. This allows objects to complete a loop in less time compared to orbiting Earth. In other words, you could circle the moon more quickly. Picture this. If you were standing on the moon, watching satellites zip around Earth at thousands of meters per second, then turn to see a probe orbiting the moon, gliding by at a much slower pace. This contrast in speeds is like witnessing a cosmic speed race. Here's an incredible fact. If you were on the moon driving at 25 kilometers per hour, you could almost circle the moon in less than a week. More precisely, one trip around the moon's circumference would take just a few days. By contrast, even at the same speed on Earth, it would take over a year to complete a full loop. I've got to say, this comparison is pretty mind-blowing. Once we grasp these basic scientific principles, we can better understand and predict the behavior of satellites, space probes, and even the orbital dynamics of future space travel. This knowledge is vital for global communication, weather forecasting, geographic information systems, and deep space exploration. It's critical for testing and development. Imagine this. You're out in the vast expanse of the universe, quietly watching objects orbit Earth and the moon, racing under the influence of different gravitational forces. Scenes like these aren't just about science. They're also a testament to the limitless imagination of humanity. So here's to that, including the GPS you rely on every day. Its pinpoint accuracy all hinges on the speed of satellites in Earth's orbit. Next time you use your navigation app, look up and give a little thanks to the sky.